Okay, let's look at example 4, graph the reciprocal function. Now that we have looked at the inverse variation model, let's talk about the reciprocal function. How could we graph a reciprocal function y equals 1 over x, where k is equal to 1 and x and y are inversely related, so they vary inversely. The reciprocal function, which is when your variables are inversely related, maps every non-zero real number to its reciprocal, which means you just have to graph all the points possible that you can map. So this is going to be a little bit hard in the beginning to understand, but as you see the trend, as you see the pattern, you'll be able to understand how to graph them. So first of all, step 1, consider the domain and range of the function. Think about the restrictions. What are some values that domain will not have, or the range could not have? So in your domain, your x cannot be 0 because anything over 0, when your 0 is in the denominator, it is not possible. It's not a real number. So x cannot be 0. It will be undefined. And then that means, will y ever equal to 0? No, because your numerator is always 1. There is no way you will have a 0 for y either. So y cannot be 0 either because it's just impossible to get it with 1 over x, where x is not going to be 0. Okay, so now we have identified the restrictions for our domain and range. Let's look at the next step. We're going to graph the function using some table of values. So think about when x is equal to 0, it's undefined. What about some other numbers? When x is equal to positive numbers, right? If it's a whole number, we have a fraction, right? Because your equation, remember, is equal to y is equal to 1 over x. So whenever x is a whole number, it's just a fraction in the denominator. So when x is equal to 1, it's 1. When x is equal to 2, is 1 over 2. But then when x is equal to a fraction, then your y becomes a whole number, right? So it's actually a big number. The smaller your x becomes, and closer to 0, the smaller positive number you have, the bigger y value you have. Isn't that funny? Yeah, this is because you have a reciprocal relationship, an inverse relationship. So yeah, so whenever x becomes greater, then y becomes smaller because it's a fraction. We have a fraction, right? Yeah, so think about the negative numbers as well. It's the same way, except in your negative values, the absolute value of your negative values become greater when absolute value of your negative values of x becomes smaller. So it's in the same way. So if you start plotting the points, 0 is undefined. So when x is 1 over 3, when it's like fractions and you have a whole number until you have a 1 comma 1, and then your y becomes fractions, and then it gets smaller and smaller, and then it gets closer to 0, but it will never be 0 because you will always have a fraction, right? So even if you have 100, x is 100, you will have 1 over 100, and that's a really small number, but it's still not 0, right? If you have 999, you will still have y that's equal to 1 over 999, and that's also a really, really small number, which is close to 0, but it's not 0. So it will, in theory, never equal to 0, but it will approach 0. forever and ever. In the same way over here as well, your y value will approach infinity, positive infinity, as x gets closer and closer to 0, but they will never touch. So this invisible line, which we'll talk about soon, is called the asymptote, where by theory you will never touch. You'll never be able to touch the line. There's an invisible line that you will never touch, but your graph is approaching towards. So it's gonna get really close to the asymptote, but your asymptote will never be reached. Okay, so in the same way, your negative values for x will also have the same shape. So follow these numbers one by one and try to understand what's happening here. This is called the inverse relationship or the reciprocal function 1 over x. So now that we have graphed an approximate graph here, let's observe the graph as it approaches positive infinity and negative infinity. As we have talked before, it will approach the asymptote. The asymptote is a line that the graph approaches, but it will never be touched. Yeah. So they guide the end behavior of a function. Your end behavior tries to reach it, but it will never reach it at all. As x approaches infinity, f of x approaches 0, but it will never be 0. And as x approach negative infinity, it will also approach 0, but it will never be 0. So this is a horizontal asymptote. You also have a vertical asymptote here. As x approaches 0, your y values approach negative and positive values, right? Yeah, so if it's coming from the right side, it approaches the positive infinity. If it's coming from the left side, it approaches negative infinity. So the directions are also important in this case, because when x is approaching 0, it could come both ways, from the right side, from the left side. Yeah. So this is also the vertical asymptote. So in a reciprocal function like this, asymptotes are very important because they will tell you where your graph should approach and how your graph should look like. So pay attention to finding these asymptotes, and in order to find these asymptotes, defining your range and domain in your first step is very important, because without having restrictions, you won't have any idea where to start from. So start from domain and range, and then you'll be able to map some important points and see the pattern. So let's look at try number 4. Graph the function y equals 10 over x. What are the domain, range, and asymptotes of the function? So instead of 1 over x, now we have 10 over x. It should still be similar, but you should be able to figure out some different points. Okay, so pause the video, see if you can graph them by yourself. Graph the major points, the significant points that you can have, and and figure out where the asymptotes are, where your graph is approaching. Okay, come back when you're ready for answers. Okay, are you ready? So, when you graph this function, you will have the same domain, where domain cannot be, it could be all real numbers, but it cannot be 0, right? And same for y. Y could be all real numbers, but not 0. So the restrictions for domain and range are the same. But what's different is your 10, right? So how does that make a difference? So when you make a table of values, for example, when x is equal to 1, instead of 1 over 1, we have 10 over 1, right? So when x is 1, it's immediately 10. Yeah. And then when x is equal to 2, it becomes 5, right? And then when x is equal to 3, 3.33, and then 4, 2.5, and then until when x is equal to 10, you have 1. Yeah, so this is 1 comma 10, and this is 10 comma 1. And then you'll notice that we also have the same end behaviors where as x approaches positive infinity, y will approach 0. We have a horizontal asymptote here. And then as x approaches 0 from the right side, y will approach positive infinity. And then in the same way on the negative side, you will have negative 10 comma negative 1. So we have negative 10 comma negative 1. And then we have negative 1 comma negative 10. And then, in the same way, we have a horizontal asymptote as x approaches negative infinity and y will approach 0. And when x approaches 0 from the negative side, your y approaches positive infinity, and we have a vertical asymptote here. So this should be the major points that would be different. And then, and that should be how your graph looks like. It looks very similar to the example that we looked at, except these points. And so looking at this graph, we can figure out the domain, range, and asymptotes of the function. And it's very similar to the ones we looked at just now in example 4. So domain is all real numbers, but x is not 0. And then range is all real numbers, but y is not equal to 0. So this means not equal to. It should be like this. Yeah. And then what else? Asymptote. So there is a horizontal asymptote where y is equal to 0. That is the horizontal asymptote, right? And then there is a vertical asymptote where x is equal to 0. Yeah, so your graph will never touch this line where x is equal to 0 and y is equal to 0. And that makes sense because our domain does not include zeros, and range does not include zero at all either. So everything makes sense. Good, so that was example 4 and try number 4. Let's continue with the last example in the next video.